or the transmission loss due to two different string cases. The only difference is the impedance in this case has to be changed to oblique wave impedance. Okay, so how much is transmitted is again totally governed by the impedance of two medium. So let's extend what we learned to the case that would have a more general physical circumstances. Okay, suppose we have a plate and I use coordinates x and y, and then let's denote amplitude of this wave eta, amplitude of this wave, in other words, amplitude of this wave as eta, and that is a function of y and t that I write that has complex amplitude a exponential minus j omega t, and that is propagating in positive y direction, y and minus with some wave number kb. Kb is the wave number, in other words, number of waves that allows to propagate in a two-dimensional infinite plate. Okay? Then suppose I have incident wave, then due to this impedance mismatch, there is abrupt impedance mismatch. Again, there is impedance mismatch. Some wave will be reflected and some wave will be transmitted. Okay. Right? Let us then write PIRT at the same time. Okay. PIRT is of course a function of space and time, where R is a function of x and y. Then I can write that has complex magnitude okay, and then it propagates with some wave number, right? So exponential, fluctuating in time with the frequency omega, okay, and it will propagate in positive direction. So I invite wave number vector for incident, reflect, and transmit, and R vector. Right? That is perfectly okay. We would like to know what we want to know. what is, how much wave is reflected compared with Pi, and how much is transmitted compared with the Pi. That's what we want. We especially want to know this, transmission. Okay? How can you find this? Yeah, again. Based on pressure and the velocity continuity on x equals 0. Right? That's what we have been using all the way. Right? So if I ask you, write down what boundary condition we continuously use for flat surface of discontinuity problem, then you can immediately write pressure and velocity continuity, right? I will promise that I will make that problem in final examination. If there is some student who, if Yang-Hann made the wrong answer, then we will make his midterm examination score to 0, right? Okay. So pressure has to be continuous. How to write it? Pressure in this side would be Pi plus PR, magnitude on x equals 0. Okay, and then I have what? Exponential minus j omega t minus something that I have, that one is ki in y direction, that has to be cosine or sine. Sine theta I, and then y, and I also have a kr sine theta r in y direction, and so on. And those has to be same, therefore we can also conclude that the same geometrical relation that related with wave number, that is ki sine theta I, has to be same as kr sine theta r. Of course, therefore theta r and the theta I has to be same. Therefore I will take out all this, and then I have pressure PT, and I have also same exponential term, exponential minus j omega t, blah, 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 blah. And that has to be equal to what? That is a force, net force acting on the plate. Okay? So I have to write here the equation that governs the motion of plate. That is m d square eta dt square. What is it? That is inertial force acting on unit area of the plate. And also I have the force due to the bending rigidity. And I write B as a bending rigidity, then I write right on x equals 0. This is on x equals 0.